Today I have the homework. So we're going to do right now is going to be writing the code, which I pre-wrote it. So this is a brief video recording. So we want to write an 8051 assembly code that perform the n divided by 7 operation, n, which is going to be like any number you choose, and display the reminder in port 1 where n is the number read from port 0. So we have two numbers. One is in port 0, which is n, and we need to display the result or the reminder in port 1. So for this one, this is my code, wait, let me do it again. Okay, this is my code, which is first we're going to do the routine, which is original 0h and ss jump xx. So we have ss jump xx, which means that the system or the operation is going to jump to xx, which is from here is going to jump here. So we have move a p0, which is right now is going to be like moving the number n, which we said that it's in p0 to a or accumulator, and move b uh, hashtag 07h, which is going to load the 7 number, the divider, into b, into register b. So, and then we have div, which is division AB. So it's going to be A over B, which A, like we said, is N from port 0, and B is 0. B is 7 that we get from hashtag 07. So we get the results in B, from B to port 1. We get the result from B to port 1. And because for operation division, for the division operation, is going to do the division and then store it in B, in register B. That's why. And then we end with the routine again, routine of endless loop or infinite loop. So we can do SS jump, which the system going to be end here, obviously, and then end. So we build it, and you see here 0, but 3 ones, and we do debug, and we do step by step system move the n to a, and then load the 7 into b, and then the division, and then load the result from b to port 1, and then the infinite loop, which is the infinite loop, obviously. And to know what happens in the memory, you can just obviously look at the descent. So for the first operation, which is move or like ss jump, if you look at here, you can see 8,000, like 2 bits, 2 bits, or like 4 bits, or like 4 Ds, let's say 4 Ds. So, and you look at the memory, you can see the exact 4 Ds, like 2 Ds, 2 Ds, like 8000, and if you look at the next one, it's like E580, E580, and 75F007, 75F007, and obviously going to be like this till your last line or last comment. So this was for the first one. Okay, I will delete it and I will write the next one, the next assignment, which say write write 8051 assembly code that perform data transfer from internal data memory as described below, using the indirect addressing method and the DG and Z, which mean uh, like it's like decrease if it's not 0. So if the value of what you are decreasing is not 0, it's going to continue. until zero. That's what happened. Like if you say degree dgnz r1 slash x2, if r1 is not zero, so the operation is going to x2, wherever x2 in your command is. So it's going to x2 until what register you typed in the dgnz operation became zero. That's why we need to go to the next line and create a loop to transfer the data from addresses 1918 until 10 hertz to addresses 20, 29, 28 until 20 hertz. Okay, I have the code ready, which is this one. I'm going to copy it and paste it here. But before that, I need to do a build because in the last one, there was a not the same command, not the same assignment, not the same command lines. But if I do now, it's going to load the previous one. So I need to build it. Okay, zero error, three warnings. Okay, start with the routine, original 00H, and then let's jump X. So I have the X. Now I pointed move R0 19 hits, R0 hashtag 19 hits, 19, yeah, 19 hits. So now I pointed R0 to source start addressing 18 hits. Now my starting address is 19 hits, which is R0. R0 is going to be the starting point or the starting address. And then move R1 29 hertz. So I pointed at R1, well, not yet, but I did. So now 29 hertz is going to be R1. Whatever data in 29 hertz is going to be in R1. And for R2, R2 hashtag 0 A hertz, this is the loop counter for me. And the loop counter, it's dependent on this one, dependent on the data you use in here. So it's going to be like counter. So for A, the zero here is not like it's not counted because it's to the left. So I have A, which is 10. So now the loop counter for me is going to be 10, which is going to be similar to this from because I want to go from this one or like from this one to this one. Or from this doesn't matter, but the loop counter is still is going to be 10. So now what do I need to do? For now, I have to use I used indirect address mode. I have to use indirect addressing method and the DGNZ. But for the DGNZ, if I want to use the DGNZ, I have to have like a register that to point to the operation and destination. If it's this register is not going to be zero, you need to go there and decrease again until this register is going to be zero. So I will start it by x1, or you can start by like b1, s1. It doesn't matter. That's up to you. But I'm going to start by x1, which is move a at r0, which is going to what this operation is going to do is going to like read data from internal RAM or address of r0 and move it to a. And then I will use the clear carry flag and then subtract a at R1. So it's going to subtract like a minus the address in R1 minus borrow if there is a borrow. And then I will use then I have the move at R1 command A, which is going to store the data into internal RAM R1 at the address of R1 at its address. And hashtag is data. So if I say hashtag 29 hertz. In 29 hertz, there's a data. But if I say at R1, in at R1, there is an address at R1 which I want to move in A or like any other place. So move at R1A, which is going to store data into internal RAM at address R1. And then I have the decrement, which is going to, it's always a decrease. So decrement R0 and decrement R1. Okay, now I have the DGNZ decrement counter and bit, if not 0, DGNZ R2 slash X1. So for this one, because R2 is not going to be 0 until the destination is going to be 29, the operation is going to X1. It's going to here and then start from here again from this line. It won't go up, won't go from here. We'll start from this line and then again until it reach DGNZ R2 until R2 becomes 0 or reach 0. Then it's going to the next slide, which is the infinite loop, the routine of the infinite loop. We have like three routines: original 00 heads, S jump X, and many for the infinite loop and end. This is our routine in every comments we use. And if yeah, I did a bit of work. Let me try again. So step is going to X, obviously. Step, the next one, like the previous assignment. Next one is going to clear the flag, C3, in the memory IDC. Subtract with borrow, move, decrement, DNZ. In here, the trick is going to be always in here. So R2, if R2 is now is going to be, if R2 is 0 now, it's going to the next line always, if it's 0. But because R2 is not 0 now, because R2 now is 10. So it needs to go down until it reaches 0, obviously. So if I do the step, it's going to X1. Then again, if it's not 0, again, 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 maybe like 5 times. And the infinite loop is going to stop at the infinite loop because it's infinite. And thank you, that's all for this video, and I hope to get your feedback if I missed something or like missed some information. Thank you.